So here you are, trying to do your math homework. You get stuck partway through a calculation, so you ask your teacher or friend what to do next. They tell you that at this point, you should cross-multiply. And you say, "How was I supposed to know to do that? I thought I already passed this test in grade 8. Why does stuff in math keep coming up again and again? And also, how do you cross-multiply again? I forgot." If that is what you're wondering, then this video is for you. My name is Clara Tong. I tutor math online to students in grade 8 through Calculus 2. I help students improve grades, build confidence, and achieve goals. Alright, cross-multiplication. You probably learned cross-multiplication as part of the unit on proportion when your goal was to solve for x. If I scale up this fraction, what is the value of the numerator? One way we can solve this is by using algebra. Since in this case x is being divided by 9, we multiply both sides by 9 to undo the division. Your teacher may have also taught you this shortcut where you multiply on the diagonal and divide by whatever is remaining. In effect, this is the same as undoing the division in the first method. Memorizing what gets multiplied and divided is convenient because we can just autopilot the procedure to find x whether it's in the numerator or denominator. For example, if you're solving a proportion where the numbers are not nice, you could just pull out your calculator and type the following. In these two previous examples, our shortcut worked very nicely. But what would you do if you saw a proportion where x was in more than one position? So here is a more general procedure for cross-multiplication. You can see that we still have two fractions that are proportional to each other. The letters a, b, c, d are not variables. They're just placeholders. A represents the numerator in the first fraction, b represents the denominator in the first fraction, c represents the numerator in the second fraction, and d represents the denominator in the second fraction. The reason why this works is very much like why our shortcut worked in the first two examples. We were just multiplying out both denominators now. So we have a times d equals b times c. How can we apply that to this question here? It's easy to see what letters 2, 3, 4, x, and 5 belong to, but you may be wondering about that x plus 4. It actually goes with the a, since the invisible denominator is 1. After cross-multiplication, we need to use other algebra skills to isolate x. Remember to distribute that 10 into the x and the 4. We need to get all the x's on the same side of the equal sign, so I'm going to subtract 10x from both sides. Finally, x is being multiplied by 2, so I'm going to divide 2 on both sides. Here are some other examples where a times d equals b times c is applicable. A times d is the same as 3 times x. b times c is the same as 2 times all of x plus 10. Remember to distribute. Get all the x's on the same side of the equation by subtracting 2x on each side. And we have x equals 20. Same thing for the next equation. B is equal to all of 3 subtract 2x. So a times d is the same as 3 times x, and b times c is the same as 5 times all of 3 minus 2x. Remember to distribute. To get all the x's on the same side of the equation, I'm going to add 10x to both sides of the equal sign. And to undo the times 13, I'm going to divide 13 from both sides. To summarize, we cross-multiply whenever we solve a proportion. That is, whenever we see one fraction equal to another fraction. We can use x equals b times c divided by a whenever there is only one x in the proportion. But we must use a times d equals b times c when there is more than one x in the proportion. Here's a pop quiz. Can you match the situation to the category? Pause the video and give it a try. This one has one fraction times another fraction, not one fraction equals another fraction, so it belongs in the neither category. For this situation, you don't cross-multiply. You first reduce and then multiply across. The rest of these situations fall under the cross-multiplication category. There are two equations in which x appears only in one position. Because this one has an x plus 3, I'm going to leave it for now. I'm going to move the other equation over to the x equals b times c divided by a category. It doesn't matter if b, c, and a have squares or square roots or fractions or whatever. We are still going to multiply the diagonal numbers together and divide by the other number. As I mentioned before, these brackets just go with the numerators of the fractions, so we have an a over b equals c over d situation. I'm going to put this equation over here, which then leaves the last one for the either category. By now you should understand that a times d equals b times c will give you the following. You remember to distribute the -9, distribute the 8. Gather all of the x's on one side of the equation by adding 9x to both sides. Gather all the numbers on the other side of the equation by subtracting 40 from both sides. X is on the top right, so I'm going to multiply the 7 and the 6 together because they're diagonal from each other, and then I'll divide by the remaining number, 8. To further isolate x, I need to subtract 3 from both sides. To subtract fractions, we need a common denominator of 4. And our final answer is 9 over 4. Using a times c equals b times d, I get the following. Distribute the 8. Get all the numbers on one side and keep the 8x on the other side. Divide by 8. Reduce the fraction. And x itself is equal to 9 over 4. So you see both methods work, and whichever one you choose is up to you. Hopefully, you have a better understanding of when and how to cross-multiply. With enough practice, you'll be able to automatically do it on your own. If this video helped you, give it a thumbs up. If you have a question about math that you would like answered, comment down below. And don't forget to subscribe and hit the bell icon for notifications. See you next time!
Is that it?